Hello, ninth graders. So we are continuing on with our 7.1 notes today. We are going to talk today about permutations. So what we talked about with the fundamental counting principle is we had all of these options for different slots, and we are still doing that now. But whereas before with fundamental counting principle, things could repeat, right? If we were talking about a true-false test, you could choose true every single time, and that can repeat. Permutations will have specific slots, so a specific order that we want to put it in, but we cannot have repeats. Permutations, I tend to think about in reference to rank, when you're trying to rank something in order, or if you have a specific spot that something goes into. So we're going to see a few examples of that. So here's the first example. Mr. Coelty and Mr. Shantz were playing N64's Mario Kart. When it came time to pick characters, Mr. Coelty chose Mario. Mr. Shantz immediately started making fun of Mr. Coelty's choice, since, in his opinion, Peach was the far superior character. Thus, a heated debate began about the top character choices for Mario Kart. We have now all been asked to rank the top 3 Mario Kart characters. How many different possibilities are there? So we have a specific position that we need to be putting these characters in. We have first, we have second, and we have third. And we want to know how many different possibilities are there for the picking of those characters. Well, if we were to just start with the first, second, and third, and let's say that, like, okay, I chose Mario to be first place, and then second place I chose, from there I have Luigi, and then third place I'll say Peach. Realize that when I choose somebody for first place, like Mario, now for second place, I don't have 12 options I don't have 8 options anymore. I have 7 options. So where there were 8 options for the first place, now there are 7 options for the second place. Then for the third place, since we've already used those 2 characters, you can't list a character as first and third. Now we have only 6 options left for the third place. And so this idea, if we're thinking back to the fundamental counting principle, we had 12 options and then 12 options and then 12 options and then 12 options, and we multiplied all of those guys together. Here, what we have is 8 options and then 7 options and then 6 options. And so then we take those numbers and multiply them together. 8 times 7 times 6, which is, 336 different possibilities for ranking the top 3 characters out of 8. So this is what we call a permutation. A permutation is an arrangement of objects that occur when order matters. So when we're ranking something first, second, or third, or maybe we're trying to pick a specific arrangement of plants along a wall. And first I want to do this one, and then I want to do this one. And it's not necessarily a ranking of the best plant, but it is a specific spot that the plant goes in. So order matters, and no object can be used more than once. There is a formula that you will be using. How we look at permutations, how we talk about permutations, is it looks something like that. NPR. N is the number of objects, number of options that you have. So let's write that in. N is the number of options. So for our ranking of the N64 characters, of the Mario Kart characters, up above, the number of options would be 8. R is the number of positions. So for the example above, that would be 3 positions. So for the example above, it would be 8p3. And how we calculate that is we use something called factorial, which in your opening video for today talks a little bit about factorial. Factorial is the exclamation mark that you see after numbers. I think some of you have asked me about it in the past. I think I remember one of you asking me about it after you guys took your standardized testing. And it just means that you're multiplying in sequential decreasing order. So 27 factorial would be 27 times 26 times 25 times 24 times all the way down to 1. So notice that pattern up above here. We had 8 options, and then we took away 1, and then we took away 1. So it was 8 times 7 times 6. But it's not times 4, 5 times 4 times 3 times 2 times 1. We don't use the rest of those positions because we don't care about the rest of those characters at that point. We only care about the top 3. So it's not just n factorial, but you have all of those numbers. Let's show you up here. If we did n factorial, that would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But we only care about these ones, which means we need to divide out the remaining. So we need to divide out 5 times 4 times 3 times 2 times 1 so they go away. They cancel out. That's 5 factorial, which is 8 factorial divided by 8 minus 3 factorial. Remember that 8 is the number of objects you have, and 3 is the number of placements that you can mete out. So that translates down to this formula down here. We have the factorial of the total number of options, but we don't care about all of the options. We just care about a certain number of the options. So to then divide out or eliminate the rest of the options, we have to subtract out how many placements we're looking at, and then divide out that number factorial, and that will give us the permutations. So this is the formula. We're going to practice using it. It probably looks pretty crazy right now. I also want to write down how to use your calculator, because your calculator could also just calculate this whole thing for you. Okay, so we're going to write it down, and then you can use it later. So just for right now, write down. You have to be in the calculate section, so not the graphing section. You go from menu to 5, which is probability. Probability. And then from there, you go to 2, which says permutations. Permutations. And then what shows up on your calculator screen is what is our formula, which is nice. And then it has parentheses. What you put in the parentheses is the N, and then a comma, and then the R. Not those exact letters, but you put in those numbers that go in for N and R. And then you press enter, and it will give you what the number is. So you can try it from our previous example up above. Try going into menu 5, 2, and then do 8, 3, and it will give you 336. Okay, so those are 2 different ways to calculate it. Because of how this year has gone, you will never have a test this test will be a calculator test. So now you know how to use that. For future years, when you are going to potentially be asked things like this on your IB exams, since I'm assuming most of you are on the track for an HL math IB course, there will be tests that are calculator tests and some that are non-calculator tests. If it's a non-calculator test, I'm pretty sure permutations and combinations, which we'll learn in our next class, are in the formula packet. So these formulas will be provided to you in the IB exam, or you'll have it on your calculator. So either way, as long as you understand what factorial is, the N and the R, and how they all play into it, this is all you really need to know.